Marsman, and I have been with Microsoft for about 13 years now, so I am essentially a grandma at Microsoft. And one of the things that I have noticed over my time at Microsoft is that there is a real culture change happening. All right, and especially in the last 2 years, I think we're really seeing the battleship turning in a new direction, especially in regards to open source software. So my teammate Casey spoke yesterday about our open sourcing of .NET and the Roslyn APIs and some of that cool stuff. And so today, what I want to focus on specifically is our cloud story. So some of the openness that we've got going with our cloud, which is specifically Microsoft Azure. So Azure, from the beginning, has been a very open platform. When it was very first launched, even at the very beginning, there was support to put up websites in this cloud using not only ASP.NET, like a good little .NET developer would, but also PHP and Ruby and Python and all these other languages as well. We have Node.js support. We have all kinds of good stuff. And then there's also the capability to put operating systems up, so run whole virtual machines in our cloud. And so we give people the option to do several Windows operating systems. There's a whole lot of different Windows options, but we've also supported Linux from the very beginning. And there's a number of different distributions we support. We support Ubuntu, we support CoreOS, OpenLogic, SUSE. So there's a number of different options up there and available, and different versions of each of these different options. So again, from the very beginning, it's been doing that. And then there's also something called Azure Mobile Services, and that's specifically kind of a back-end as a service when you want to do mobile development. And from the beginning, we've supported not only a Windows Phone, but also Android and iOS devices. So there are APIs you can call and code you can write in Objective-C to call into Azure Mobile Services. And what that gives you is all the things that you typically need when you're doing phone development. So typically you need like a database in the cloud, right? Especially if you want to sync among multiple things, or you don't want to have to store a lot of things on your phone. So it gives you database capabilities, it gives you auth capabilities, it gives you push notifications. And again, it's not just through our Windows push notification framework, but we also integrate with Google Cloud Messaging, which is how you do push on Android, and Apple's push notification service. So just very inclusive and kind of open on Azure from the very beginning, from the get-go. And we continue to kind of add new things in there. So one of the newer things we have added is the support for big data. So in the big data world, there is something called Hadoop. And so it is an Apache project, Apache Hadoop. And currently it is like what the industry uses for big data. And so for the rest of the talk, I'm going to focus on kind of what we've done in our path and cultural journey, specifically with Hadoop. All right, so I mentioned Hadoop is used for big data. Now, just to level set, let's make sure we're all on the same page about what big data is. I know some people, when they're new to it, are kind of like, okay, where's the cutoff? Is it just like data, and then that plus one is big data? Like, how does that work? So big data, when we're talking about big data, typically we're talking about the 3 V's of big data. And the first of those is data volume. So when you're working just at a certain quantity of data, that's considered big data. Obviously, if you have petabytes, those kind of things, just massive amounts of data, exabytes, even terabytes, that's just a lot of data to play with. And those kind of things are considered a big data problem. So when you think about industry trends right now, like the Internet of Things, in those scenarios, there may be sensors on various things, and they're all sending data up to the cloud. And then we want to do analytics or something interesting with that data. So a couple of examples. I know there are some cases where farmers are using little sensors like on their fields, and the sensors can measure things like light and rainfall and wind speeds and all of that stuff, and then push the data up there and then be able to make intelligent choices on like which fields to plant and those sort of things. There's also a really amazing connected cow story that I really want to tell, but there's not time. So I think I've already like told some people at the conference, but go to YouTube and look up connected cow. There's a guy, Joseph Saroge. There's, I think, a video clip of him presenting it at Strata in New York. And it's awesome. It's amazing stuff. So volume. Volume is the first thing. The second is data velocity. So what I mean by that is when you have a problem where data is streaming in real time and you want to be processing it like in near real time or near real time. So in those scenarios, that's also like a big data problem. And the scenario I always think of for this specifically is that in a hospital. So I think it was about 5 years ago, I attended, fairly close to here, the Kentucky celebration of women in computing. And one of the women that spoke there was a PhD. I forget if she was academic or from industry. There's a lot of healthcare stuff in Kentucky. But she spoke on and told us how you can actually predict when a heart attack is going to happen in a hospital if the right sensors are hooked up. So think about when you go in the hospital and they put all those sensors on you and they're measuring your blood pressure and your heart rate and all these other, millions of things. And so they actually have the knowledge to be able to detect when cardiac failure is going to occur. But we weren't doing it because we couldn't keep up with the processing. And that just infuriated me, right? Like the fact that we had the ability, like we could potentially save lives, we could predict that people were gonna have heart attacks, but we weren't doing it because it was just too much processing overhead to hook up like every person who came into these types of things and then do all that monitoring and processing. So another thing that got me really, really passionate, like 5 years ago, whenever this happened, about big data. And then the last V is variety. It's also sometimes called versatility and some other Vs. But essentially what I mean by this one is the concept of you have data from lots of disparate sources. So a scenario where you might want to do something like this is March Madness. Let's say we want to write like a machine learning algorithm and we want to figure out, we're going to up our chances in the poll and do some machine learning to try to figure out who's going to win March Madness tournaments or whatever. Okay, so now my lack of basketball knowledge is going to start to show here. But the things so we probably want a whole bunch of different kind of sources of data for that. And let me just kind of make it more generic because my baseball knowledge or my basketball knowledge is going to fail me here. But let's say football or something. So like in a football scenario, since it's played outdoors, you might want to grab weather data, right? Because when a team from the south comes up to Michigan, where I live, and tries to play in the snow, they're going to have some problems. So maybe weather is a factor in how well people play. Maybe things like injuries. You want injury reports, and grab that too. You need individual team stats. You need kind of team collectively, all of those different stats. And then, of course, the features that would go in differ depending on what sport you're looking at. But all the stats that everyone tracks like crazy during when you're trying to pick out your fantasy team, all of those things need to play in. And then another thing that might be an interesting factor is just like raw emotion, Like I know when Michigan plays Michigan State, and like Michigan State won the previous year, like Michigan comes back with a vengeance, right? They are mad. They want to win this year. So things like that. So there's all these different factors and stuff where we might want to draw in and use those together. And so that can also be considered a big data problem. So all of these three Vs, either kind of by themselves or in combination, are kind of what make up the big data realm and this big data thing that we want to conquer. So at this point, big data is out there. People are doing it. People are using it. So we're faced with a strategic decision. Microsoft wants to be involved with this. We want to be able to provide big data solutions to our customers. Like, what do we do? What do we do about big data? So Microsoft is, I got a few laughs there. I did not think I would. I'm like, Sex and the City, I'm not sure that will fly with this target audience, but I'll give it a try. So okay, we got like one laugh. So that, by the way, is Matt Winkler, who is the head of the HD Insight team, which is the Hadoop running on Azure team. But in this scenario, Microsoft does have experience with big data. So we essentially have done like stuff in the past, like there's Bing. Bing runs one of the largest data centers in the world where we're keeping essentially, our copy of the internet for doing, search engine stuff. We also have Azure, of course, and Azure's running our, we've been monitoring the health and bringing machines up automatically when they fail and all of that stuff for a long time. We have all of the telemetry data that comes in from Office and Windows, and that has a lot of users and stuff, so we've been managing that for a while. And then things like Xbox Live, oh my gosh, so all of the Xbox Live users out there and just handling that. So we did have experience in the space of big data. So because we had this expertise already, it really became a question of, build versus buy, right? We had the expertise, so we could potentially build something ourselves, or we could choose to buy something or adopt, a solution that's already out there in the open source world. And so I'm really excited that we did actually make the decision to let's use what the industry is already using. And I think that kind of speaks to some of the culture change that we're seeing at Microsoft, because 10 years ago, I don't know if that would have been the decision, So we decided to go ahead and adopt Hadoop. Now, Hadoop is an Apache project. It is open sourced in that manner. And Hadoop, essentially what it is a distributed, it's distributed processing, right? So you spin up a big cluster of machines, and you have a main controller, and it kind of uses the MapReduce pattern and farms out a whole lot of work to all these different worker nodes, and then reduces down and gives you some output. And I'm way oversimplifying things. If you want to talk about it in more depth and talk about some of the other pieces of the Hadoop ecosystem, because there's a lot of other stuff in there, NoSQL database, which is HBase, and Hive for real-time processing, and all this other stuff. So if people want to talk about it more later, come find me, because I'm happy to go geek out a little bit more on this. But essentially, this is what it is and what it does. And Hadoop had essentially gotten a lot of momentum in the industry. Cloudera and Hortonworks were already kind of building enterprise quality Hadoop distributions. Facebook was using it. It had, I think, enough momentum in the industry that we decided that, yes, it's reached escape velocity, and we're going to go ahead and adopt Hadoop and have that run on Azure. And one other point I want to make, just in the realm of the database world, you see a lot of companies like Microsoft and IBM and Oracle, and we all have these proprietary solutions for databases, right? Oracle and SQL Server and stuff like that. And Facebook had adopted Hadoop. So this Hadoop infrastructure was running kind of alongside, at the same level, at Facebook scale, with best of breed things like Oracle and SQL Server. So that just kind of speaks very highly to the quality of open source software and the kind of things, amazing things that people are doing with it. So I thought that was really awesome. All right, so we're going with Hadoop. We know that. So the next question was, how do we do that, right? Do we to fork or not to fork? How do we move forward? Do we branch fork our own distribution and maintain our own distribution of Hadoop from Apache? Do we go with one of the existing ones out there? I mentioned that Cloudera and Hortonworks already were maintaining their own, enterprise-grade distributions of Hadoop. And so those were options and such. And essentially, we decided to go with that. So again, Microsoft chose not to build it ourselves, but to use an existing thing, which was kind of cool. And so we partnered with Hortonworks, and we're using their enterprise distribution and running that in Azure in our data centers. And one of the reasons we chose Hortonworks specifically is that I think we were very aligned in kind of how we felt about this. And Hortonworks have always said that their mantra is Apache first. So like all the great stuff that they're doing, they make sure gets back into the Apache Hadoop. And so that kind of mentality of, rising waters lifts all boats, right? We're all in a community. We're going to help each other out and make it better for everyone. And that was very much aligned with how we were feeling with Hadoop as well. All right, so the next question. Now that we decided we're going to go with Hadoop, and we want to make it run, and it doesn't run on Windows. So we're going with the solution. We're going to work with Hadoop. And Hadoop was written in Java, and Java. Write once, run anywhere, right? Yeah, it didn't work on Windows well. So the first thing we had to do was go forward and actually make it work on Windows. And that kind of got us into the open source community, kind of step by step. So the very first thing that had to happen was the team that formed the big data team at Microsoft was our existing data team. So this was a group of folks from the SQL Server team. So these guys are, PhDs in, database theory and query optimization and stuff like that. But we didn't have a lot of Java expertise. So kind of starting out, we had to learn Java and make sure people kind of get up to speed with the language and adopt another language. And then the second step was just actually participating in the open source community. So kind of getting to know the culture and understanding how it works and what the right etiquette is and that sort of thing. And then we started submitting issues and patches and that sort of thing and contributing a little bit. And then the first priority there was just ensuring that Hadoop would run on Windows. So do kind of the baseline work to get it working on Windows. And then after that, we got it working on Windows. Next step was to actually get it working well on Windows. So the Hadoop running on Linux still just massively outperformed Hadoop running on Windows. And so we were like, okay, what can we do to up our game here? And so we ended up having to dive like really deep into like how the JVM interacts with NTFS and the specific like Java APIs that are calling into the Windows APIs. And so it was really interesting to kind of, we had to do some low-level stuff, but we ended up doing a lot of good work there and then contributing it all back to, the main Apache Hadoop to make Hadoop run really well on Windows. And then we even got to the point that some folks became committers into Hadoop, which is pretty cool. So for those of you who came to this conference to learn more about the open source community and may not be familiar with the term, when you're a contributor, what that means is that you can submit bugs and issues and here's a request or kind of submit my code fix and that kind of thing. And then committers are the ones who actually have write access to the source code. So they're the ones that approve those things and actually can write them in. So we got to the level that some folks at Microsoft are actually committers on Hadoop. So that's great to kind of have that vote of confidence that we were good contributors there. All right, so where was it hard? Let's talk about where we kind of struggled a little bit. The first thing was just a complete culture change, right? Again, we had this group from SQL Server, so these Microsoft devs who had written SQL Server and were PhDs, really good at query optimization and database theory and this kind of thing. And they're now working with the open source world, which some of them didn't have that much knowledge of. So things like just sparring with random people on a listserv type feeling was a new, different experience. The other thing was just around just timing of work and workflow and how that went. We, as a corporation, we set deadlines, right? We have milestones or sprints or that sort of thing, but kind of dates where we want to try to get stuff done by. And when you're working with the open source world, like a lot of people are volunteers, all right? And you can't push your timelines on other people. So we had to do some adjustments there and figure out how to make that work well. And then people had to kind of be smart and make sure they allotted time. So I'm sure like when we first started, we were probably submitting things and into the tree, like, okay, here's a sprint's worth of work, and okay, give that back to me as like 50 different submissions. So all kinds of things, but just kind of learning and working at that right pace and trying to figure out how to make deadlines and stuff like that. But it really kind of grew this new culture at Microsoft. So we were getting there, we were kind of fumbling a little bit, and I don't want to say that we have it perfect yet. I'm sure we don't, positive that we don't, but we're learning. And we've actually seen some things that have been kind of changing that make me really excited. So the first thing, I think a really key turning point here is the fact that when we started, we were all about like making Hadoop run well on Windows. And that's awesome, but that's kind of a self-serving goal, right? It's helping us to make it run well on Windows. But there's an initiative called the Stinger Project, and that's another Apache thing for trying to optimize and make some of these things run faster. There's a whole kind of group of them, Taze and some of these other things are also in that camp. And so this initiative, one of the goals was to make Apache, or these things run faster. And Hive is a query language, so kind of like SQL, for working with Hadoop and HBase and others in the Hadoop ecosystem. And so it wasn't performing as well as maybe it could. So we were looking for ways to make it better. And so what happened is we took, these PhDs in like query optimization who had written SQL Server, and they were like, well, you know what? Based on all the stuff that we know from writing SQL Server, we know ways to make this faster. And they wrote a paper called the Hive 100 and basically put together ways to make Hive run, for some queries, 100x faster. All right? And then we took that and partnered with Hortonworks and Facebook and others and contributed all of that back into Hadoop. And like that is awesome when you think about it, right? Because that was essentially like intellectual property, right? This was some of the, I want to say trade secrets, but it was intellectual property that we used to help make SQL Server so great, and we were giving it back to the open source community. And so like that's something I'm really proud of, and another thing I think that signals that culture change that you wouldn't have seen that maybe 10 years ago. So in summary, like a bunch of SQL Server developers are writing Java code now to improve and support open source. Like that's awesome. That's really, really cool. Another point is there's something that we introduced at Build in April called Azure Data Lake. And essentially what that is it's like the underlying storage for a Hadoop cluster. When you spin it up, kind of the industry standard for the underlying file storage is something called HDFS. the Hadoop distributed file system. And with the data lake, what we're doing is taking kind of that standard and making it available like in our infrastructure. And so again, I think what that really shows is that we were looking specifically OSS, and what people are using now is shaping the investments that we're making today. And it's funny too, because I see the team and we look at what are people using right now, what are the most popular tools, where is the open source community going, and then we're making decisions based on that. And like, that's awesome. Like, open source really is helping drive and shape this product. So in summary, there's just been so many kind of cool things around the Hadoop story that I found. These numbers, don't quote me on these numbers. I pulled kind of an old slide, so these numbers might actually be even bigger now. But at the time I made the slide, it was about over 10,000 engineering hours that we were using, and over 30,000 lines of code contributed back into Hadoop. So that's awesome. We were responsible for helping get Hadoop on Windows working. We had the Hive 100x query speed up. Some of the people at Microsoft advanced to the kind of point where they're committers into Hadoop. We offered that HDFS service in Azure Data Lake so that we're using what the open source community wanted to use in our system. So all of these things together, I think, just have me so excited about the way, kind of how the battleship has turned and how Microsoft and open source are working together much better now. And actually, I think the big data team, like the Hadoop team here, is actually hiring. So if anybody wants to be part of this awesome culture change, let me know. But I'm just so excited about where we're going, and I just can't wait to see. Although we're not perfect, I think we're finally turning that battleship in the right direction. Thanks a lot.